Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone, and thank you for joining us today. We're going to take a deep dive into how you can accelerate data transformations with Dataflows Gen2 in Microsoft Fabric. My name is Miguel Jopis. I'm a group product manager working on the data integration team here at Microsoft, and I have a pleasure to have my colleague, Jeroen Ludwiller, with me. Hey, Jeroen, how are you doing?
Doing good, Miguel. Looking forward to the session today. So my name is Jeroen Ludwiller, part of the product group as well, and focused on data destination for Dataflows Gen2.
All right, thanks, Jeroen. Let's dive right in. We have a lot to cover, and we're going to go really from 0 to 100 in this session. We're going to start by talking a little bit about the key challenges around data preparation and how Power Query and Dataflows can help you with that. We'll give you an overview, and we'll give you deep dives into a bunch of things that we've recently launched and things that are upcoming as well. We're going to do a lot of demos today. So with that, a little bit of a context setting. I'm sure many of you have seen this slide and heard this speech before, but I'll just mention that Fabric is the industry's first converged data management platform. And it was founded on the very premise that the fragmentation across the data management solutions in market creates real friction for customers. Customers are not able to get maximum value from their data, and it ultimately gets in the way of them harnessing the power of AI. This means that Fabric unifies all the aspects of data management, including data integration, real-time operational databases, analytics, and business intelligence. It's all built on top of one lake as the unified storage platform, and it has governance and AI features and capabilities built in. Now, let's look at how Data Factory within Fabric supports all the major data integration critical capabilities. That includes rich data connectivity to hundreds of data sources, the ability to move data from those data sources as well, orchestrate a wide range of data processes and activities, transform the data, including low code and also code first experiences. We have an entire range. And then deploy all of that with the right set of deployment options and the observability capabilities, the ability to monitor how your artifacts are doing once you've deployed them and operationalized them. Now, Data Factory offers best-in-class connectivity through hundreds of connectors, and this allows us to just give you access to all data sources no matter where they reside, whether it is on-prem, in the cloud, or behind VNets and firewalls as well. But then it comes the real challenge, data preparation. What do you do once you have that data? So before we look at the product, let's start with a little bit of a reality around those challenges. So the first challenge is simply finding and connecting to the right data. It's really, really challenging. The connectivity experiences are often fragmented, different tools, different query languages, different endpoints you have to connect to. So people have to learn them all. You need to learn different tools and workflows depending on where your data lives or where the data lives that you need to connect to. And then once the data is connected, okay, first couple of challenges down, the data usually needs to be cleaned as well. Data is never in the right shape. And it doesn't mean that the data is dirty. It just means it is not exactly shaped the way you need for the thing you're trying to do, right? You just have building blocks. You need to further reshape them and finesse them and tweak them so that they fit your purpose. Very often that data shaping is not only tedious to do, but it's also not easily repeatable. It's very often a one-off. And in many cases, you need to do the same types of transformations and reshaping on the data over and over as you reconnect to that data source in the future for new projects. The last second to bottom item here is about combining data from multiple sources. So we all know data never comes from a single place. Whether it is databases, files, data lakes, web services, right? You name it. There's many, many different sources of data. and you need to pull them together. And at that point, you not only need to bring data from 2 or 3 or 4 different sources, but also you need to rationalize it. Perhaps you need to join data across these sources. And then there comes the problem of keys, foreign keys, primary keys, ways to reference data across these tables and join it together, right? Normalize units of measures, normalize little changes like uppercase versus lowercase for the same field, right, across different tables. And of course, the last point here is about the 3 V's of big data. We always think volume when we say big data, but really the challenges of big data come in 3 forms. So obviously, data is large. That's the first and foremost challenge, but then the velocity of change for that data changes a lot. Imagine that a scenario I was talking about where you're connecting to 3 or 4 different tables in different data sources. Some of these table sources may vary on a weekly basis or monthly basis, perhaps a list of customers, a list of products, right? But many other sources actually change very, very often, every minute, every few seconds, right? Think near real time, think transaction data, things that change very, very rapidly. And it's up to you as the person preparing and combining that data to rationalize that and make sure you end up with as a result is actually coherent and something that you can actually make sense of. The last point here, of course, the variety. As we said earlier, variety of the data sources that you're connecting to, variety of the data shapes that you need to deal with, and just having to bring it all together is really, really challenging. All right, so here comes Dataflows Gen2 to the rescue. How can Dataflows Gen2 help? First of all, Dataflows Gen2, as we said earlier, includes hundreds of connectors, over 170 built-in connectors. These are connectors built by Microsoft or third parties and certified and shipped by us. That gives you really a broad set of ready-to-use options for connecting to the most common systems and services across files, databases, of course, Fabric, Azure, Power Platform services, many other online services, and third-party connectors as well. With that, of course, One Lake Data Catalog enables the seamless discovery of data that's already within Fabric. That is actually very easy to discover other lakehouses, other warehouses, other SQL databases within Fabric that you may have access to and maybe recommended to you. And really that experience, the get data experience is what brings it all together. Doesn't matter if you're trying to bring that from a new source or connect to something you already have in Fabric, we just streamline the experience and make it all readily available for you. Once we're connected to that data, the preparation experience is familiar by design. We are actually leveraging the Power Query experience that is already used by tens of millions of people across many different products, including places like Excel, Power BI, the Power Platform, Dynamics, and of course, within Fabric. As you may already know, we've been with Power Query in market for over a decade. I think it's been almost 15 years at this point. We have a huge, passionate community of, as I said, tens of millions of users leveraging Power Query on a monthly, on a weekly, on a daily basis. And lots of community collaboration, lots of tips and tricks, common recipes, and a lot of things that you can find through forums and community and books and many, many different resources available to you, many of them for free, actually, so you can actually master Power Query and, make sure that it fits your purpose and further optimize it. The last but not least, I'd like to say we started powering Power Query experiences with AI before AI was a hot topic. We've had features like by example data extraction and many others for many years. And as of late, we've also added a lot of Copilot-based capabilities, AI transformations, the ability to just provide AI prompts to achieve your purpose. And it's all just turnkey in the product. No need to type a single line of code. If you don't want to, of course, we have a full code behind language with the Power Query formula language that the UI generates, and you can go and fine tune and optimize, or even just read aloud if you want to understand it. But you don't need to. You don't need to learn code if you don't want to. And the last point I wanted to raise here is really that Dataflows Gen2 is actually built for enterprise scale, and it's actually widely reusable. So if you think about these two terms, they're actually very important. One of the common pain points for Power Query users leveraging Power Query in desktop environments like Excel or Power BI desktop is the lack of scalability, the lack of the ability to compute, massive amounts of data, right? That is now available within Fabric because we leverage Fabric compute behind the scenes to actually give you the ability to lift and shift and transform, really large amounts of data, petabyte scale of data. And the other key point here is, again, if you go back to the early Power Query days, Power Query in Excel, Power Query in Power BI desktop, it was all about bringing data through Power Query for something very specific. Loading data into an Excel workbook so then you can actually crunch data in the workbook or in the spreadsheet, right? Or create a pivot table, perhaps. Likewise, in Power BI, bring data to a specific semantic model to build a specific report. Now with Dataflows Gen2, we've actually lifted the Power Query capabilities. So now you can widely reuse the output results, which you can load to many different destinations, whether it is destinations in Fabric, destinations in Azure, things like Azure SQL Database, Azure Data Lake Storage, things like SharePoint. Jeroen is going to walk you later through how to load data to SharePoint through Excel files and CSV files. Things like third-party databases like Snowflake and many more that we have coming up soon. So really the goal is for us to give you Power Query for whatever you need. Use the Power Query experience, the low-code experience to create your data flows, to create your queries, automate it, and load the data to the place where you want to take it. With that, we're going to look next at some of the recently introduced performance improvements. Jeroen, over to you.
All right, here we go. Let's share which screens. All right, thank you, Molly. As Miguel said, one of the biggest challenges is, of course, working with your large set of data coming from your various kind of sources. But even if Dataflows Gen2 is scalable to handle that kind of data, it needs to do it in a reasonable amount of time as well. So what we did is we implemented various improvements to the performance of Dataflows Gen2 since its release. And we'll first watch a video and then go over a few of the features in details.
Performance isn't only about refresh. It's also about how quickly you, the author, can build and iterate. That's where design time performance comes in. One of the most common parts of authoring Dataflow Gen2 is the data preview. Every time you add or apply a new step, you want to see how it affects your data. But those previews can be slow. In this example, almost 18 seconds to load. That slows down iteration and makes it harder to refine your transformations quickly. So here's where enable only and preview changes the game. I'll go to my source step, and instead of pulling in thousands of files from storage, I'll filter down to just a small subset that I actually want to use as sample data. I can right-click this new filter step and set the enable only and preview to apply during preview. Notice the banner at the top confirming it's active. Now, when I refresh the preview, look at that, less than 3 seconds instead of 18. This means you can move step by step with instant feedback, making design time authoring dramatically faster, smoother, and far more productive. That's feedback we've heard directly from you, and we acted on it. Next, let's look at execution performance. Again, this is directly from your feedback. You told us refreshes needed to be faster and cheaper. We've benchmarked Dataflow Gen2 using the New York City taxicab dataset. First with a single year of data, and then across multiple years. Even at baseline, Dataflow Gen2 was already cheaper than before. But here's where things really improve with the modern query evaluator. Watch closely. We've set up a three-way comparison. On the left, you see the original Dataflow Gen2 pipeline with no enhancements. In the middle, you see it with the modern query evaluator. And on the right, you see it with modern query evaluator plus parallelism. Take a look how they progress. The left pipeline takes the longest, chugging each step while the timer keeps climbing. In the middle, the evaluator alone is already much faster, cutting runtime by 40 to 50% in both single-year and multi-year tests. But the real breakthrough is on the right, with partitioning and parallelized executions added on the top of the evaluator, multiple transformations run at once. The result, the refresh finishes dramatically quicker than either of the other two. This means even lower costs and effortless scalability for larger data sets. This is the power of the modern query evaluator. On its own, it brings big gains in speed and efficiency, and when combined with parallelism, it completely changes what's possible with Dataflows Gen2.
And that's impressive, right? You can see that by just adding a few more improvements to the Dataflow Gen2 engine, we were able to get so much faster. And especially for the New York taxi dataset, you can see that if we compare, for example, the 5 CSV files, the 32 gigabyte yellow taxi data set, we compared to Gen 1, we are 65% faster, and compared to Gen 2, the old engine, we're actually 45% faster, meaning that we gaining much more improvement over time, especially for you if you want to run day-to-day refreshes. You can do it in a reasonable amount. So what is this modern query evaluator? So if you go to the Dataflow settings, you can enable it and allow the Dataflow engine to use the new engine instead of the former engine. This engine is built on the new .NET Core and is way more optimized for handling the big size chunks of data. It's only available in Dataflows Gen2 with the CI/CD option. So if you're still running the old Dataflows Gen2 in your workspace, you are probably going to benefit from just upgrading to that new version alone on speed, but also on cost, which we will hit on a bit later. Going to the next one is that we just looked at the preview only steps feature. What this does essentially is that on the right-hand side, you always have your list of query steps that you're applying on your data. So let's say I'm working with a large Snowflake database with millions of records of orders that's coming in every time. However, in just working with the data, I just need one chunk of data. Let's say I need 100 rows. To make sure that I'm shaping the data as I want to, transforming the columns, maybe doing some pivots. But if I have in this data preview the full data set all the time, I get into a performance bottleneck, right? Because every time I'm applying a step, I need to get the whole set of data from the server. And that's not efficient because you just want to apply a step and want to see a preview of the data of how it looks like. So what you can do is within the step pane, you go to the first few steps. Let's say you just got your data and you didn't do any transformations yet. What you do, you add a filter step, and this filter step could be top 1,000 rows or filter on the specific date. And once you do that, you do a right click on this step in the query steps on the right hand side, and you say I enable only in previews, which means that during refresh, when you saved and publish your data flow and it's running a day-to-day job, it's not applying this filter. But when you start editing this data flow, it does use this filter, allowing you to do quick edits, making sure that your validation of the data flow goes much faster, giving you essentially a speed bump during your editing of your data flow. Now, one more thing you've seen in the video is the partition compute. The partition compute allows your data flow to, for example, process multiple CSV files at once. If you have a source like the New York taxi dataset, which consists of 5 CSV files, what you normally would have is that it will get all the CSV files, processes them one by one in sequence, and then basically plumps the output to your data destination. What partition compute allows you to do is essentially getting those 5 CSV files at once, putting them in the staging area, and then allowing to work on those in parallel, which means that with this overall improvement is it allows you to do things in parallel, which is much faster in the end-to-end refresh time. It's basically optimizing the time spent and diversifying the compute it's used for moving that data along. This is, of course, only when your data is already partitioned in the CSV files before. So if you have cross-partition operations, that would probably not work. But if you have just a single file that has all the operations within that file and then being processed, that should be fine for the partition compute. So give it a try. Follow our documentation on the partition compute, and hope it brings you benefit in processing more data. Then we added a few more aside from the demo that we just watched, and that's the fee order compression and MD sync settings. So within the Dataflow settings, first we added a fee order compression that you can enable or not. And this is only talking about the stage data. So what you're seeing for the stage, for when you stage your data into the staging lakehouse or staging warehouse, is that by default we apply a fee order compression, and the fee order compression makes sure that the data is ordered in such a way that it's useful, for example, for a direct lake model. So if you're writing to a data destination, you have that option there as well. You can enable the fee order compression on that one as well. When you enable that, it will be helping the performance of the direct lake model. But when you're working with data that just needs to move from your staging to your lakehouse destination, you probably wouldn't need this fee order compression applied on the data, which allows for less processing time during the refresh. So we have a rule of thumb, which is shown here on the deck. It's basically you turn it off in general for staging to get a better performance, because in most cases, staging wouldn't need the or would not benefit from the fee order compression being enabled. And only turn it on when you face any issues with staging. So when you're using the Dataflow connector and your refresh is slow to your semantic model, you might want to turn it on if you're facing issues. For lakehouse destinations, again, turn it off if you want to have better write performance, but you turn it on when you want to benefit for better read performance. So like with direct lake models, they always read from the data source over and over again. So in those cases, it will be helpful for the direct lake model to have an ordered Parquet file to read from. A second option that we added was actually MD sync. And this is an option that we only added to the data destination part of the Dataflow settings. And what it basically allows you to influence is that if you write your data to a lakehouse, there needs to be some kind of a metadata sync between the SQL endpoint and the file-based storage that we use for all the data, right? But this takes some time, and you can say, I want to make it part of the refresh, or I don't want to make it part of the refresh. And in general, it's advised to keep it on. It's often just takes sub-seconds to do so. But if you're not using the SQL endpoint anyways from your lakehouse, you can turn it off if you'd like. But in general, we say you turn on the MD sync, as it allows for completing the refresh, including the metadata sync to the SQL endpoint, making sure that you don't see any still data on any subsequent data flows that consume from the SQL endpoint, or any Power BI report that may consume from this lakehouse. There is then one more option that we added. Again, this is an insane option if you face this specific scenario. And what we basically added is that we have optimized the way that we write from our staging warehouse to lakehouse. What previously happened is that the staging warehouse to lakehouse copy operation was taking a lot of time to move data from the staging warehouse to lakehouse. So therefore, we advise users, if you want to see the best performance and your scenario calls for a staging query to be included, we basically said it's best for you to also write to warehouse, because warehouse to warehouse copy is pretty fast. But what we have done now is we actually included an option that allows this copy operation from the staging warehouse to be more efficient to the staging lakehouse. And this is currently in preview, but if you have a data flow that takes a long time to refresh, and in the scenario you see on the screen right now is that the original data flow was taking 56 minutes. And this is a very hyper-optimized scenario where we would benefit from this option. But you see that by just enabling this option, this data flow refresh went from 56 minutes to only 6 minutes, because it took such a long time to move from the staging warehouse to lakehouse. And now with the new setting, it's just minutes to just move this much data. And this is 36 gigabytes that's being moved in 6 minutes through the Dataflow engine. So definitely worth to look into that. And get the benefit from that as well, because the less time you spend on the data flow, the less CU you consume from your capacity, the more you can do with your data flow. And talking about CUs, this is where we also did a new pricing model that we included on the Dataflow Gen2. So what we had before, we consumed basically 16 CUs per second while your data flow was running. So it didn't matter if your data flow took like an hour, 2 hours, or 3 hours. For every second, we basically consumed 16 CUs from your capacity. With the new tiered pricing that we introduced in the Dataflow Gen2 with CI/CD, is that the first 10 minutes will be 12 CUs. So that's already 25% cost savings right from the start. But then if your query, so if you have a single query that takes longer than 10 minutes to refresh, so let's say you have that 1 hour query that's moving that data along, we actually drop down to just 1.5 CUs per second. Basically, giving you, for big data sizes, a better option to just have this new version of the pricing model in place for you. So if you really want to benefit, this optimization is that if you have long running data flows right now, try to move them to Gen2 or CI/CD and see the cost difference show up right away. And aside from just cutting the cost down by just reducing the price per second, or for those long running data flows, basically reducing the cost for that to 1.5 CUs, we also have added those performance enhancements. So if we just look at the benchmark that we did before, which was benchmark 1 is Dataflow Gen1, and then we compared it to Gen2, the old Gen2, and then we added the modern query evaluator, which already cut down the run duration in half from the original Dataflow Gen2. And including the parallelism, you get even closer to just that 1.7 seconds that's needed for this whole data flow to run. Looking at that, together with the CU consumption reduction, any new workload that you add that depends on this large chunk of data to be processed, give it a try on Dataflows Gen2. It should bring a bunch of benefits right now with the CU reduction and the performance enhancements we did over the last couple of months and implemented there. So with that, just want to go over a few new features that we have added. So again, Dataflows Gen2 comes with data destinations out of the box, and we're adding much more over time. And we just actually last week introduced PostgreSQL as one of the new public preview data destinations. So if you have scenarios that you want to test with PostgreSQL, go ahead. We should be able to write to any cloud where you're hosting your PostgreSQL database and just write there. What's coming soon is the Amazon S3 integration. So if you want to write to S3 buckets, you should be good to go there as well. Again, and Google Cloud Storage is also coming soon. Then Miguel already highlighted a bit is that we also support working together with your colleagues on SharePoint, for example. And we're introduced that aside from the CSV files that we already supported before, we now also support Excel files to be written over there. And let's have a look over there to this video right now.
Hello, everyone. Today we're going over a couple of new features we are introducing for FabCon in Atlanta. First of all, we're going to have a look at the Excel data destination. And the one that I wanted to look at this one for is the orders query. Orders query, we have some order dates, number of orders, number of products sold, and the total revenue, extract from our data source. This data now needs to be represented in an Excel sheet for our leadership team. In here, we go to SharePoint, select our data destination. For now, we're using Dataflow Gen2 data destinations, and hit next. With this destination now set up, we can select the file format we want to use. In this case, we're using Excel. The file name is orders.xlsx, which makes sense, and we are putting it here in the shared documents folder. We already have an orders.csv, but this time we're writing out a Excel file. We want to have a single sheet that we're writing out, but instead of a sheet, we want to have a chart in there. So we'll go with chart on this one. We give this one orders as the sheet name. We use the bar chart and then call this orders over time. There we go. We have to have an access column. In this case, we want to have the order date on the access column, and then the values would be number of orders, number of products sold, and total revenue. This should now be reflected within the chart that we're writing out. Then primary access column, as we have just selected one, we selected order date. Then with that, hit next. And this one we can just skip. The orders being written to an Excel file. We also want to write our fabric sales to a Snowflake database. In this case, we have the opportunities, the product, the regions, the sales representation, and in which states this deal is. To do this, we are going to add a data destination here, click on more, and we see Snowflake pop up here on the right top corner. However, if we look at the recent pane, we can also click it from right away here. Click on public, which would write it to the Power BI Snowflake warehouse. Within the warehouse, we can give it a table name. In this case, we just put it in the public schema database, and then we have this table name, fabric sales. We can just go ahead and click on next. Now with this set, we can go ahead and save and run this query. The data flow now finished. Now we have our data within Snowflake and within our Excel file. First, have a look at the Snowflake data. Over here, you can see the table got created. And if we look at the data preview, we see all the data that we expected to be landed here, with all the probability scores, the close date, who the sales rep is, etc., etc. Now, if we go to the Excel data that we have over here, we can do a refresh, and you'll see we have the orders file here as well. Opening up the orders file, we'll be seeing the order dates, the number of orders, as well as the overall slide show or deck with all the orders, total revenue, as expected, the bar chart. All right, this is it. See you guys later. Bye.
That's probably not the best way to.
Hello everyone. Today we're going over a couple of new features we are introducing for Facon.
1 second. There we go. That's probably not the best data set to use for writing that to Excel, but we will be coming up soon with something exciting for the Excel documents. So stay tuned for that. Then next up is the export query results. So if you're working Power BI Desktop, you have been working with Power Query for a while now. But somehow you want to maybe migrate over some of those queries into Fabric. And how you can do that is actually shown in this demo here.
Today we are announcing the general availability of Export Query Results, a powerful Power BI Desktop feature that enables users to export query results to an online destination powered by a Dataflow Gen2. Here in Power BI Desktop, I'm going to open up the Power Query Editor from the context menu on a query. In the Query Editor ribbon, I can see an icon for Export Query Results. Let's click on it. Because this is powered by Fabric, I need to select my Fabric workspace. I've picked one for this demonstration, and if you don't have one, you can easily sign up for a Fabric trial, giving you a Fabric workspace. Once I've selected a workspace, I need to pick a destination for my query results. I can either pick a brand new destination, including Lakehouse, Warehouse, SQL, SharePoint, Data Explorer, and ADLS. Or I can pick an existing destination from OneLake catalog. I'm going to pick a Lakehouse. I need to pick a connection or create one to access the Lakehouse. And that's it. Now I see a confirmation menu. A data flow will be created for me in the workspace I chose. I also notice that my connections are not linked up. This is called binding connections. It looks like I need to bind my SharePoint connection. Once that's done, I rename my data flow and click on Export. Now my data flow is created. There's a link to Fabric and starts running. This might take a while depending on the size of the query, but I've sped up the process here for the demo. Any errors we might get will show up here, and you can click through to the data flow to debug them. It looks like we finished successfully. I'm going to check my data flow in Fabric in case I want to modify it. I can click on the link and see the output of my query is in there. Export query results allows me to save my queries for further analysis without.
So especially for data that has been sitting in semantic models already, great opportunity for you to move things over from your Power BI report into Dataflows.
Today we are announcing the general availability.
Then next up, this will be the last demo on the new features that we introduced. This is the Fabric Variable Library support in Dataflows Gen2. So you might be familiar with the variable libraries that you can create within a Fabric workspace. In there, you can put in different kind of variables for dev, test, and production. And Dataflows allows you to directly call these values into your Power Query steps. So, for example, if you want to filter based on the environment on different values, or you want to have a date filter in there or anything like that, you can use those variable libraries to directly work with those in Dataflows Gen2. So let's watch the video.
We're happy to announce that the integration between Fabric variable libraries and Dataflow Gen2 is coming into general availability. And we're going to be showing you one of the cool new experiences that we're introducing thanks to Fabric variables and its integration with Dataflow Gen2. Imagine by now that I have this table. So I have this simple table. It has some numeric columns. And what I would like to do is filter this table using a value from a variable. In this case, I'm going to say that for this unit price column, I can click in here and go into the number filters. What I would like to do is click where it says greater than. That's going to display this filter rows dialog, which I'm pretty used to. Now, as you can probably tell, there is a pencil here, and this is what we call an input widget. I can enter any value or select any value from the dropdown. However, when I click on this pencil, I also see the other options that I have as input. And the new one is one that we call the select a workspace variable. So I can click here, and this is going to display the select variable dialog. So I'm going to be able to see all my libraries and all the variables within those libraries. In my case, I only have a single library in this workspace, and I can pick one that meets my current context. In this case, my context is that I'm trying to filter a numeric column. So I can use either a number or an integer. So in this case, I'm just going to select this integer and click on select variable. I can see the name of the library and the name of the variable that I've selected, and I can commit. And just like that, I was able to use a variable to filter a table without ever writing any code inside of Dataflows. And we want you to give this a try and just use more Dataflow Gen2 with variable libraries. Please let us know your feedback. Thank you.
All right, with that, Miguel, I'm handing it over to you again.
Sounds good. Thank you, Jeroen. Almost there. All right, so we've covered how Dataflow Gen2 improves connectivity, transformations, performance, and operational scale. Now let's look at the next layer, AI-powered data transformation. So to be very clear on this, our goal is not to replace the author or hide what happens to the data. It is actually to reduce the friction involved in getting your data flows ready, understanding existing work, and creating useful transformation steps. Let's take a look. Copilot in Dataflows Gen2 helps across several common activities in the authoring process. First of all, it can boost productivity by generating query steps from what the user is trying to accomplish, and this helps people move from intent to a working transformation more quickly. Secondly, Copilot can summarize a query, can explain a query. This is especially useful when you inherit a flow or data flow from someone else, return to work you created earlier, or you need to understand a longer sequence of steps. Third, Copilot can use the context of existing queries or sample data to speed up integration work. The experience is not isolated from the data flow. It can work with the material already available in the editor. The main takeaway from these three is that Copilot supports both creation and understanding, while the resulting query steps remain visible for the author to review and further extend or customize. Second pillar that we wanted to cover here is AI transforms. AI transforms extend that experience from assisting with query authoring to also applying intelligent transformations directly to the data. Users can describe the transformation they want in natural language within the familiar Dataflows Gen2 and Power Query interface. This creates a no-code path to enrich or reshape data without requiring separate tooling or a separate setup experience to apply AI. The value here is accessibility and speed. A user can stay in the same preparation flow, the same experience, express the desired outcome, and apply AI transformations as part of their data transformation process within Dataflows. AI transforms are now generally available, and as with any AI-assisted transformation, it's still important for you to review the output and make sure it matches what you really meant before you operationalize the workflow. The last pillar we wanted to cover is the Data Factory MCP server, which takes us really into AI native authoring for Fabric, and it's currently in public preview. The idea is to let agents work with the active metadata in the environment, and through conversation, an MCP agent can discover workspaces, connections, lakehouse schemas. It can author and validate M queries interactively, configure your data source connections and destinations, and then operate data flows by triggering the refresh, checking status, and helping you troubleshoot failures at refresh time. The MCP server can also extend the flow into pipelines for scheduled orchestration. So this is not only about generating a piece of code. It connects discovery, authoring, configuration, operation, and orchestration for your entire DI solutions. For developers, this is the key shift that the agent is able to reason over the actual Fabric context rather than working from a disconnected prompt. Let's look at that experience closely in a demo.
Welcome to this demo of Data Factory MCP, bringing natural language to Fabric Data Factory in one conversation. My VP needs store performance analyzed by Thursday. I know I have two data sources, one for transactions and one for targets and nodes, but don't know much more. The MCP tools start exploring my workspace in Fabric, helping me parse the data sources and their structure using existing connection patterns. The Lakehouse contains transaction tables, and SharePoint has Excel files with targets. Next, my AI client asks me follow-up questions on the time period, the metrics I'm looking for, and where I want to store results. I want to first review them and then store in a Lakehouse. It points out data quirks that it proposes to fix in M code. Now it has a plan and starts iterating on the output creation, using the data factory skills the MCP has preloaded. As it executes queries, there is a timeout because my data set is large. Skills help it come up with a strategy to optimize the query. It also fixes my data issues. Now it's going to render an inline dashboard that I will validate. Interesting. Seattle and Bellevue are close to quarterly target. However, online slipped. Spokane started strong but slipped. Everett, Redmond, and Kirkland all missed. I thought I was done, but my VP just stopped by. She has an idea and wants me to test it, tiering stores by size instead of region. She wants to know if we should move Tacoma from tier B to C given the new competition. The AI client using package skills translates my ask into 1. Materializing output into a lakehouse, and 2. Adding baseline and what if tier performance output. This MCP is a workhorse. It creates 3 queries and connects to multiple sources, saving all the output to a single lakehouse. Skills help with timeouts, optimization, and destination settings. These are packaged and open source, allowing users to customize them. I now have what she asked for. Tier A came in slightly under target. Tier B, Bellevue plus Tacoma, is close, but Tacoma drags it down. Tier C, the 4 small stores, missed by roughly minus 13%. The what if shows moving Tacoma out of B doesn't punish Tier C. It diluted the underperformance of the truly struggling stores. My Thursday review just became exciting. Wrapping up, my data flow is refreshed, my lakehouse is updated, and my data engineers and I can validate the data flows that were created in my Fabric workspace without me even opening the editor. This was just one conversation. Will you have hundreds using MCP?
Right, so what you just saw here is the value of an AI native workflow that's fully grounded in the Fabric context. The agent can help you achieve multiple stages of the job. While you remain in full control of a request, you can actually create artifacts, refine your intent through additional prompts, and verify the results before you actually operationalize them.
Welcome.
The next capability we're going to show is the execute query or the streaming API, which is currently in public preview. This API provides a programmatic way to execute Dataflow query logic and consume the results of those queries through an API experience. The streaming model is useful when an application or a developer workflow needs to begin working with results as they become available, rather than treating the query execution only as an interactive authoring task. The more broader point in the scenario here is that Dataflow Gen2 query capabilities can participate now in more application-driven and automation scenarios. Instead of ending with the query editor, the logic can become part of a larger solution. Let me show you a demo. As the recording plays, focus on the interaction pattern, how requests are submitted through the API, how the query is executed, and how the calling experience receives and works with the return results. The takeaway is not simply that a query can be run, it is that the query execution can be incorporated into any programmatic workflow. This opens a path for applications and automation to use Dataflow Gen2 query logic beyond the actual authoring interface in Fabric. Now, this capability, as I said earlier, is currently in public preview. It's a good time and opportunity to experiment with representative workloads, provide feedback to us on those scenarios that matter most to you, and things that you'd like to see us improve or refine. All right, that was just a quick demo, but as you saw there, we were able to just fully specify a query to run, a custom query to run with the M code embedded in our custom application, authenticate through the API, and get the results back. All right, with that, this is actually our last slide for today. Let's bring the story together. So just a recap of the key benefits of Dataflows Gen2. Dataflows Gen2 are packed with a lot of enterprise-ready features, things like virtual network gateway support, CI/CD and Git integration as part of the rest of the overall Fabric CI/CD and Git capabilities, enhanced ALM support, support for parameters and variable libraries, as Jeroen showed in the demo. It has significantly better performance, scale, and price points than any prior Dataflow generation. That includes a new modern query evaluator, the Fabric compute capabilities, fast copy, the partition compute, all the fine-tuning capabilities that Jeroen showed you with the optimized writes to Lakehouse, the ability to disable the V-order. Price reduction, so we highlighted here a number of benchmarks that show somewhere between a 25 to a 90% reduction in CU consumption compared to previous generations. Of course, here your mileage may vary. You should try these with your own benchmarks, your own scenarios, your own data flows. But beyond the actual runtime optimizations, we also have a lot of capabilities at authoring time, such as the preview-only steps to reduce latency within the query editor previews, folding indicators so you understand what's being pushed down to the underlying data source or not, and then, of course, the enhanced monitoring and refresh history experiences that give you the ability to troubleshoot issues and to monitor how your refresh are behaving, your Dataflow refreshes are behaving. Dataflow Gen2 provides lots more versatility with data destinations. You can collaborate with others using other Fabric workloads. You can actually reuse data loaded to destinations and use it in many other places. You can also leverage direct lake mode for Power BI semantic models if you use something like Lakehouse. And last but not least, the AI-powered data transformations with that Copilot-powered creation of new queries and steps, the ability to explain existing queries, and all the integration touchpoints and opportunities that we show with MCP, as well as the Execute Queries API for programmatic and custom application development. With that, See, I lied. It was not the last slide. It was the next of last. But we have a few minutes. But I just wanted to close by saying thank you for being here. Q&A, I don't think we'll have a live Q&A or interactive Q&A in this session, but definitely you can hit us through all our Fabric community channels, whether it is the official community, the Fabric subreddit, whichever forum you prefer to reach to us. Feel free to send any questions or any feedback you may have. We monitor all of those on a daily basis and deeply care about making you successful with our product. With that, I'll turn it back to Molly, and thank you very much.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.